Last time we were discussing numerical differentiation, and the case of unequally spaced data was considered. So let me start with the revision of what we did last time. For unequally spaced data, we have forward divided difference interpolating polynomial in this form, and the error term is in this form, and if you want to find out the derivative of this divided difference interpolating polynomial, that will give us the tool for estimating derivative values from the given data when we don't know the function, only the data, and with the data we have this function available whose derivative has to be evaluated. So we take the derivative of this polynomial term by term. Derivative of this term is 0 because this is a constant data value. Here is the variable involved. This is constant. This is the constant divided difference, and we take the derivative of this term. That will be 1. So first term in the derivative will appear as the first order divided difference. Then the next term, if we take the derivative, this term is constant. And you have the variable part this, which is in the form of u and v, u into v. So we apply u into v formula to get the derivative of this part. That will constitute the third term of the, in fact, the second term of the derivative formula. Taking this term for differentiation, third order divided difference is constant. The rest is the variable part, which is u into v into w. And these steps are demonstrated here. Derivative of y naught, derivative of the first term in the interpolating polynomial, derivative of the second term in the interpolating polynomial, the derivative of the third term in the interpolating polynomial, and so on and so forth. Using the third term, we demonstrated how to write down this product. The derivative of this term, which involves products as well as sums. So there is a summation involved, there is a product involved, product of x minus xj type terms, where every time one of the index j's has to be missed out of the product of 3, we get a product of 2 each in 3 terms, and that makes this compact notation. This compact notation can be used to write down the fourth derivative, which if we write in the expanded form, it will be very long. It will involve 4 terms, and each term will contain the product 4 terms added together, and each term will involve product of three terms of this type, and every time in the term of product of 3 linear factors will miss one of the index, and so on and so forth. So using this compact notation, ultimately we write down the derivative of the error term, and finally the derivative of the polynomial and the error term together in the compact notation, which will be further compactified in view of the fact that we have a summation. So summation को हम compact notation में लिख सकते हैं, लेकिन that is not necessary. We just want to learn the basics of taking a data set, and from that data set we apply estimation formula for derivatives we will consider if only one term, that is this one. So this is the first order derivative that will give you a very rough estimation of the derivative. We noted down that divided differences are like y2 minus y1 upon x2 minus x1, which is the slope of the line joining the 2 points. So this is an estimate of derivative, first derivative. But if you go for the estimation of first derivative of up to second order, then we'll consider formula up to this point. But for third order, we'll go for higher order terms. This term is here not written completely. In fact, in the derivative formula, x is equal to x naught is substituted, and then this is the actual formula. We considered example, and I want to start today's proceeding with another example. Here, the data was produced from a known function, but I go for a data set which is not developed from a known function. And where it is, here it is. Can you see this Excel sheet?
Yes, sir.
Okay, so I have written down only. Sorry, IB से मुझे कॉल आ रही है. Can I take it? अस्सलामुअलैकुम. अमीना, अभी मैंने क्लास शुरू की है 5, 4:30, 5 बजे तक. ठीक. Sorry for the disturbance. Now, can you see the Excel sheet? यार ये राइट साइड पे क्यों नहीं आ रहा? जैसे इसको वहां से हटाता हूँ ये गड़बड़ हो जाता है. Take it down. अच्छा जी. Here I have written derivative formula. Of course, this is only an estimate, not exactly equal, of second order. This is my data, and I will consider this data and have an estimate of derivative of second order. First derivative, but estimate is of second degree. So x is equal to 3.5 पे मुझे f prime at 3.5 estimate करना है, and let us see what steps we have to do. First of all, we have to develop the divided difference table. I hope you remember how the divided difference table is developed. Y1 minus y naught divided by x1 minus x naught. So we start with the D8 minus D7 divided by X8, that BC8, which contains X1 minus C8 minus 7, and that is the first order divided difference. And we copy paste and completely develop the table. Then second order divided difference, and I have to take 11.2 minus 10. That means I start with D9 minus D7 divided by this 4.1 minus 1.2, and that makes what? C9 minus C7. C9 minus C7. It is a second order divided difference, and we consider all possible second order divided differences. You can say that when I'm considering a second degree estimate, तो मैं x0 और x1 इस्तेमाल करूँगा, फर्स्ट ऑर्डर डिवाइड डिफरेंस इस्तेमाल करूँगा, सेकेंड ऑर्डर तो मुझे बाकी बनाने की ज़रूरत नहीं है। लेकिन डिवाइड डिफरेंस जब भी बनाए, टेबल बनाए, जब तक कहा ना जाए कि सिर्फ उतनी टेबल बनाए जितनी ज़रूरत है, तो जो डेटा दिया हुआ है उससे पूरी टेबल बना लें। Next order divided difference means 9.3 minus 10 divided by 5.2 minus 1.2. So that means D10 minus D7 divided by C10 minus C7. The third order divided difference is there, and we make all possible third order divided differences. This is the fourth order. देखिए नोटेशन की वेरिएशन करनी पड़ती है हमको whenever we write down things in different platforms. Fourth order divided difference, and let me consider 8.1 minus 10. So that is D11 minus D7 divided by C11 minus C7. So fourth order divided differences are developed, and fifth order divided difference, and I consider D12 minus D7 divided by C12 minus C7. एक ब्रैकेट लगाना मैं भूल गया हूँ, and copy it down as much as possible, and last divided difference, which is the sixth order divided difference, is equal to D13 minus D7 divided by C13 minus C7. So the complete divided difference table is developed. Now I have to first estimate the derivative of मैंने इस डेटा का प्लॉट देखें, यहाँ पे जो डेटा है वो जिसका प्लॉट बनाया गया वो यहाँ दिखाया हुआ है। सो इसका मैंने प्लॉट बनाया हुआ है और मैं एस्टिमेट करूँगा derivative at 3.5 somewhere here, derivative at 4.5 somewhere here, and derivative at 7 somewhere here. और एस्टिमेट जो है वो सेकंड डिग्री एस्टिमेट्स हैं, तो सेकंड डिग्री एस्टिमेट का मतलब मैं ये फॉर्मूला इस्तेमाल करूँगा. Now when I consider 3.5, now 3.5 is somewhere here. Going up to second order, I have to use second order divided difference. I have to use the first 3 points. So let us consider which part we use. First, you see that first order divided difference has to be written. यहाँ पे y sub 1 लिखा हुआ, it has to be y sub naught. So this value, and I copy this value from there, E7. So first order divided difference आ गया, plus second order divided difference is NF7, and this is multiplied by what? This is multiplied by x minus x naught. So what is x? X is 3.5 minus x naught, and x naught is 1.2. In fact, after that, there is x minus x1. So x is 3.5. There has to be an addition. 3.5 minus x1, and x1 is 3.4. 3.4. And a second degree estimate of the first order derivative at 3.5 is obtained. It is 2.15. Now, if we look at the data, 3.5 is somewhere here, and this is this value that we have obtained as 2.129 is the slope of the tangent. So somewhere here, the slope of the tangent is Somewhere here, the slope of the tangent is 2. The scale is not good. Let me try to format axis. And for formatting axis, मैं minimum value जो है वो क्या consider करूँ? मिनिमम वैल्यू मैं 7 ले लूँ. देखिए इससे कुछ एडवांटेज होता है कि नहीं होता. यस, now it's more clear. The scale is still not uniform. Horizontal 2 units are longer than shorter than the vertical 2 units. Anyways, at 3.5 यहाँ पे हमें slope जो है वो अच्छा खासा ज़्यादा नज़र आ रहा है, and this seems to be a pretty good result. Now, if I move from 3.5 to 4.5, तो अब मुझे क्या करना पड़ेगा? I still use the same second degree estimate. That means this 4.5 is somewhere here. तो 3 पॉइंट्स जो मैं इस्तेमाल करूँ या तो 3.4 से 5.2 तक हो या 4.1 से 5.9 तक. तो मैं ये सेलेक्ट करता हूँ कि मैं इसके लिए ये इस्तेमाल करूँगा. When I use this, what should be my first order divided difference to be used, and that should be this one. So जहाँ से मैं पॉइंट्स कंसीडर कर रहा हूँ उसी लेवल से आई एम कंसीडरिंग पॉइंट्स फ्रॉम हियर. तो मैं जो डिवाइडेड डिफरेंस इस्तेमाल करूँगा वो ये वाले इस्तेमाल करूँगा. That is the change. When I go from 3.5 to 4.5, it's still a second degree approximation, but now I'm using a different set of point out of the data. So first order divided difference is this. So I select the E8 plus second order divided difference, and that is F8 multiplied by x minus first x value plus x minus second x value. So x is now 4.5 minus first x value is 3.4 plus x, which is 4.5, minus next x value, and the next x value is 4.1. Negative 4.45, negative 4.52 आया result. So at 4.5, that means somewhere here, we have a negative slope, and our result is pretty reasonable. At x is equal to 7, मैं यहाँ पे डेरिवेटिव एस्टिमेट जो है वो आप लोगों के लिए छोड़ रहा हूँ. ये शीट शेयर कर दूंगा, इसको कंप्लीट कीजिएगा. So what is this? You have to find it out yourself. Okay, that will be a good exercise for you. But मैं बता दूं कि at 7, when you take the estimate of second degree, you have to use last 3 points, 5.9 to 7.8. तो पहला point x की value इस formula के लिए 5.9 होगी और दूसरी 6.6 होगी. Now for the same data, if I go for say a third degree estimate, मैं ये डेटा यहाँ कॉपी कर रहा हूँ और मैंने इस डेटा से अब थर्ड डिग्री एस्टिमेट निकालना है. I select x is equal to 4.5 and I want f prime at 4.5 and I have to use third degree estimate, and third degree estimate के लिए ये है. So 4.5 is somewhere here, and I have for third degree estimate I have to use 4 points. तो मेरे जिस जगह मैं इंटरपोलेट कर रहा हूँ डेरिवेटिव, उसके लिए मैं 4 पॉइंट्स इस्तेमाल करूँगा. 4 पॉइंट्स इसलिए कि अब मैं third degree estimate पे जा रहा हूँ. So one more divided difference will be used, which is third order as indicated in the formula. So let us start writing down. Third degree estimate of the derivative सबसे पहले first order divided difference आ रहा है, which is this. So it comes from E28 plus next divided difference जो formula में आ रहा है second order है. So I consider F28, which is multiplied by what? Which is multiplied by x minus x naught, x minus first value. So x is 4.5 minus first x value is 3.4 plus x minus next x value. So 4.5 minus next x value is 4.1. So यहाँ तक तो हो गया second degree estimate. For third degree estimate, I have to go further, and the third order divided difference has to be used, which is there available in G28, which is to be multiplied by sum of products. So this is a lengthy word, and we start with these two terms, that is x minus first x value, which is 3.4, multiplied by x minus second x value, 4.5, minus second x value is 4.1. That completes the first product here. Then I start with the second product, which is x minus first x value, that is 4.5, minus first x value is 3.4, multiplied by x in minus third x value. So 4.5 minus third x value is here, 5.2. So second product written, and the last product to be written is 4.5 minus second x value, and second x value is 4.1, multiplied by x minus
Sir,
d.
waiting list से students को add कर दीजिए
ओ
please.
यार, वो मैंने बहुत नीचे ले गया था वेटिंग लिस्ट को. Thank you for reminding me. कहाँ पहुंचा था मैं? I was going to write down which term? The last term, x minus second x value and x minus third x value. Minus third x value is 5.2. This product is completed, and the overall sum to be included, and that makes 4.5 पे second degree estimate आया था -4.5, but 4.5 पे जो third degree estimate आया वो -3.4 आया. Okay, 4.5 पे negative slope तो है, but we consider that this estimate is better. This estimate is better because it is third degree, and I leave for your exercise to find an estimate of the derivative at say 5. So I will share this sheet and you practice for taking derivative at ये तो 5 तो negative ही आएगा. I go for what say 2.5. Now 2.5 is here between first and the next x value. Third degree estimate के लिए 4 पॉइंट इस्तेमाल करने हैं, तो what you should be using is from here to here for these green colored values of x, and let me color them green. I hope you will be able to do that exercise. you have to find out this estimate third degree. So that is the revision of how to take find out the estimate of derivative from a given data set. And I proceed further using what kind of data set, which is not equally spaced. So where we have used the derivative formulas for divided difference interpolating polynomial, like I discussed this last time. And you have to focus on how to use the formulas for estimating derivatives when data is unequally spaced. So our main formula that we have developed is basically this written in compact form. But in non-compact form, to write down the formula is a lengthy business. लेकिन जब भी हम प्रॉब्लम करेंगे तो हम इस तरह से डिटेल करके लिखेंगे, और अगर आप प्रोग्रामिंग कर रहे हैं तो प्रोग्रामिंग में ये सब चीज़ें कंट्रोल की जा सकती हैं. किस तरह से? सम टाइम आई थिंक आई विल डिस्कस दैट. Because I will, I'm planning to have some sessions in which I will discuss how to develop programs for different methods. Coming to equally spaced data. Now, equally spaced data, क्या मैंने last time equally spaced data के बारे में derivative estimates के लिए कुछ भी discuss किया था? मुझे याद आ रहा है कि इस टेस्ट में डिस्कस कर चुका था. Okay, let us review that. हमारा जो इक्वली स्पेस डेटा है उसके लिए जो इंटरप्रेटिंग पोलिनोमियल है उसमें हम चूँकि कंसेक्यूटिव एक्स वैल्यूज़ के दरमियान डिफरेंस सेम होता है तो हम डिवाइडेड डिफरेंस की वजह से फॉरवर्ड डिफरेंस इस्तेमाल करते हैं. और जिस पॉइंट पे हम एस्टिमेट करना चाह रहे हैं और जहाँ से हम शुरू कर रहे हैं अपनी एस्टिमेशन या हमारा डेटा जो हमने जहाँ सेलेक्ट किया है वहाँ से जिस पॉइंट पे एस्टिमेट किया जा रहा है उसका डिस्टेंस निकाल के एच से डिवाइड करके एक नया वेरिएबल बनाते हैं एस, सो दैट when we take the derivative of this, we keep in mind that previously we are taking derivative with respect to x, but this forward difference interpolating polynomial जो है वो उसमें independent variable x नहीं है बल्कि independent variable उसके अंदर s है, and s is defined in terms of the actual independent variable x like this. So when I take the derivative of forward difference interpolating polynomial with respect to x, so I will have to have a change of variable. So multiply and divide by ds. So ds by dx from here is derivative of x minus x naught is 1. So 1 upon h is the value of ds by dx. So अब उसके बाद जब मैं derivative of p and s लूँगा तो यानी forward difference interpolating polynomial which is dependent on s, अब मैं derivative ले सकता हूँ उसका with respect to s. So recall the format of forward difference interpolating polynomial, that is starts at the first y value, then s into first order difference, s into s minus 1 divided by 2 factorial second order difference, s into s minus 1 into s minus 2 divided by 3 factorial third order forward difference, and so on up to the nth. So nth term contains in the interpolating polynomial s minus 1, s minus 2 up to s minus n minus 1 divided by n factorial. देखो कि जो फैक्टोरियल और जो ऑर्डर ऑफ डिफरेंस आ रहा है s माइनस जो इंडेक्स है वो उससे एक कम पे रुक जाता है. That is how this last term is written. अब हम इसके टर्म बाई टर्म डेरिवेटिव लेना शुरू करते हैं. So see that the derivative of y naught is 0, whereas the derivative of s times delta y. Delta y, that is the forward difference, first order forward difference is constant. Derivative of s with respect to s is 1. Then the derivative of the next term, so 1 upon 2 factorial. Second order forward difference is a constant. We have to take the derivative of s into s minus 2. चाहे तो इसको s square minus s लिखकर derivative लो, या u into v लगा के derivative लो, it is 2s minus 1. कॉम्पैक्ट नोटेशन में जाओ या ना जाओ, हमें प्रॉब्लम सॉल्विंग के लिए नॉन कॉम्पैक्ट चाहिए. कॉम्पैक्ट नोटेशन हमें प्रोग्रामिंग के लिए चाहिए. नेक्स्ट टर्म दिस वन, इसका डेरिवेटिव लूंगा तो 1 upon 3 factorial into third order forward difference is constant. u into v into w लगा कर जब मैं इसका डेरिवेटिव लिखूंगा तो it will again have a sum of products. Every product contains two linear factors as we had before. So that is the derivative of the third order term, and the fourth order term differentiated, and this time 1 upon 4 factorial, and fourth order forward difference is constant. And here we have product of 4 linear terms. So we will get 4 terms added together, each containing product of 3 linear terms. So u into v into w into whatever, 4 हैं तो फर्स्ट टाइम s माइनस 3 का डेरिवेटिव ले लिया, सेकेंड टाइम s माइनस 1 का डेरिवेटिव ले लिया. अब जो जिस तरतीब से भी लेना चाहो ये 4 टर्म्स बनेंगी. So that is the derivative of the fourth order term. Hence the last term derivative can be written as this, which will require if we go for programming, and the error term derivative is this. So in compact form, the derivative of forward difference into product polynomial is written here. Error term derivative is written in the compact form. And if I consider derivative at x is equal to x naught and use the complete formula, I have a simplification. ये simplification कैसे आती है? x naught के लिए s 0 होता है. जब s 0 है तो ये 0 0 हो जाएगा. Let me add it here. At s is equal to 0, which is equivalent to x is equal to x naught. So what will happen to this whole thing? मैं इसको यहाँ तक कंसीडर कर रहा हूँ, not the compact notation. So जब x is equal to x naught रखूँगा, बल्कि मैं इस टर्म में अगर 0 रख दूँ तो तुम कहोगे सब कुछ 0 हो जाएगा. नहीं, आफ्टर टेकिंग डेरिवेटिव हम इसमें 0 रखेंगे s की जगह. So what will be this? ये term 0 gone, ये term 0 gone, so minus 1. इसी तरह if I go for the same kind of thing, for the next term, so I will put s is equal to 0 in this. So when you put 0 into this, ये दोनों terms गायब हो गई, because इसमें s मल्टीप्लाई हो रहा है, so 0 मल्टीप्लाई हो रहा है, तो ये दोनों terms गायब हो जाएंगे. अब जो बचेगा वो क्या है? इसमें तुम 0 पुट करोगे, ये खत्म, ये खत्म. So it will be in fact what? Positive 1 and 2 factorial cancels with 3 factorial and the denominator becomes only 3. इस तरह की सिंप्लीफिकेशन करते चले जाएंगे तो s इज इक्वल टू 0 के लिए जो मेरा पास फॉर्मूला बनेगा या डेरिवेटिव रिटर्न एट x इज इक्वल टू x नॉट विच इज s इक्वल टू 0, ये फॉर्मूला बन जाएगा. I talked about this last time कि हम इस फॉर्मूले को किसी और मकसद के लिए लेटर ऑन इस्तेमाल करेंगे. So we now are going to use the formula for derivative estimates that is obtained from forward difference interpolating polynomial. So let me collect the terms that will involve all that. सबसे पहले तो इसमें ये आएगा. So where do I collect these terms? Let me collect before I discuss the example. So पहली चीज तो फर्स्ट ऑर्डर डिवाइड डिफरेंस आ रहा है, फर्स्ट ऑर्डर फॉरवर्ड डिफरेंस. सेकेंड टर्म जब हमने डिफरेंशिएट की तो सेकेंड टर्म डिफरेंशिएट करके क्या मिला? वी ऑब्टेन्ड दिस थिंग. So plus ये. Now first order forward difference and estimate of first derivative. The lowest or the worst kind of estimate. But second order forward difference जब इस्तेमाल किया तो फिर it's a better estimate. इसमें थर्ड ऑर्डर भी इंक्लूड कर लें तो थर्ड ऑर्डर का डेरिवेटिव हमारे पास कहाँ लिखा हुआ है? यहाँ लिखा हुआ है. Now it becomes derivative estimate for what? An unknown function for which equally spaced data is available. I put this into bracket because इनमें से हर टर्म के बाहर जो है एक 1/h है, जो कि हमने टर्म बाय टर्म डिफरेंशिएशन लेते वक्त छोड़ दिया था. ये 1/h बाहर वाला. Okay, what was the fourth order term that was derived? That was this. So I copy this also there and include it inside the bracket plus. Now, this becomes an estimate of f prime x, rather s, because now the function is a variable of s, dependent on s, and this is only approximate. So I put approximation sign. Where is the approximation sign? This. अगर मुझे सेकेंड डिग्री फॉर्मूला इस्तेमाल करना है तो सिर्फ यहाँ तक इस्तेमाल करूंगा. अगर थर्ड डिग्री इस्तेमाल करना तो यहाँ तक इस्तेमाल करूंगा. फोर्थ डिग्री इस्तेमाल करना तो यहाँ तक जाऊंगा. ठीक है जी. Now वैसे मैं इसको s क्यों लिखूं, है तो बेसिकली x ही. द पोलिनोमियल इज अ फंक्शन ऑफ s, और वो सारे चेंजेस जो s के आने की वजह से हैं वो सारे हमने यहाँ कंसिडर कर लिए, स्पेशली 1/x 1/h is taking care of all that. This is the end formula. I have written or collected terms up to fourth degree. That means involving first order difference, second order difference, third order difference, and the fourth order difference. So let us see what example we are working on. We have to estimate the derivative at 3.3 with the cubic polynomial, yani third degree estimate karna hai humne that is created if we enter following table at I is equal to 2. Acha ji. Third degree. Third degree means you have to go up to what? You have to go up to this third order divide difference, third order forward difference. Now, substituting what values? Okay, can you see the whole page now? I've gone into full screen mode for Word.
I think so, yes, sir.
फुल पेज नजर आ रहा है तो ये है डेटा हमें 3.3 पे डेरिवेटिव एस्टिमेट करना है 3.3 लाइज बिटवीन 3.1 एंड 3.7 क्यूबिक पोलिनोमियल लेना है तो हमें 4 पॉइंट्स लेने हैं सो 3.3 के 2 पॉइंट ऊपर और 2 पॉइंट नीचे सो ये जो ग्रीन शेडेड पार्ट है मेरा इस फॉरवर्ड डिफरेंस टेबल का इसमें हमें ये डेटा इस्तेमाल करना है एंड हियर इज द फार्मूला ऑफ कोर्स मुझे ये सारे काम करने के लिए सबसे पहले क्या करना पड़ेगा सबसे पहले एच कैलकुलेट करना पड़ेगा एच कैलकुलेट होता है जिस पॉइंट पे मैं डेरिवेटिव एस्टिमेट कर रहा हूँ 3.3 तो 3.3 minus first x value that I am considering. So 3.3 minus 2.5 gives you 4 by 3. So h की value जो है 0.6 यानी difference between two consecutive x value. Whereas s की value आई है 4 by 3. अभी भी मेरे पास स्पेस जरा कुछ कम है मैं जरा वापस जा रहा हूँ और स्पेस बढ़ाने के लिए सो दैट आपको ज़्यादा चीज़ें एक वक्त में नजर आए Okay, I think now it should be. मेरे ख्याल अब कंप्लीट वर्कआउट जो है वर्किंग जो है वो नज़र आ रही होगी दिस इज द डेरिवेटिव फार्मूला दैट आई हैव टू यूज क्यूबिक पोलिनोमियल मींस थर्ड डिग्री दैट मींस थर्ड ऑर्डर डिफरेंस तक जाना है एच की वैल्यू 0.6 है जिससे कि एस निकाला हमने एस की वैल्यू आई 4/3 अब जब मैं डेरिवेटिव टर्म्स लूंगा तो बाहर सबसे बाहर 1/h आएगा 1/0.6 then what is the first number that I have to write down is here the first order difference that I have to use is 10.06 plus next term is what 1/2 second order forward difference so 1/2 यहाँ लिखा second order forward difference यहाँ लिखा what's the rest of it rest of it is s plus s minus 1 मैंने इसको इस फॉर्म में लिख दिया s minus 1 plus s minus 0 so what's the next term the third degree term 1/6 है इसके अंदर 1/3 factorial third order difference है third order difference is this 5 point नहीं कौन सी टर्म लिख रहा हूं मैं Yes, third order difference is 6.771. 6.771 आ गया. And three terms, each containing product of two linear term, s minus s1, s minus 1, s minus 2, then s minus 0, s minus 2, then s minus 0, s minus 1. So s was calculated to be 4 by 3, so 4 by 3 minus 1, 4 by 3 minus 2, 4 by 3 minus 0, 4 by 3 minus 2, 4 by 3 minus 1 is skipped here, 4 by 3 minus 0 is skipped here, and 4 by 3 minus 2 is skipped here. And then summing them all up is giving you derivative at 3.3 as a large number, around 27. Acha ji. Let me take this data to the Excel sheet that I was using. I will work on the same Excel sheet. Where is the Excel sheet? Where is the Excel sheet? What I do here is copy that data and plot the data as a smooth curve. And I see that it's sort of a exponential or a sort of a, yes, it's more an exponential. And see that scale on X is only very large, whereas, scale on X is small and on Y axis is very large. तो मुझे इसकी ज़्यादा अच्छी पिक्चर के लिए इसको वर्टिकली एक्सपैंड करना पड़ेगा. स्टिल 3.3 पे जब मैं स्लोप निकाल रहा हूँ, इस पॉइंट पे जो टेंजेंट ड्रॉ करूंगा मैं, लेट मी यूज माय एनोटेशन. सो अगर 3.3 इज समवेयर हियर एंड आई वांट टू ड्रॉ अ टेंजेंट, बहुत अच्छी फिगर है नहीं, बट आई होप यू अंडरस्टैंड दैट the tangent should be intersecting with the blue curve only at one point. ये tangent बना. अब मेरा estimate क्या है कि 3.3 पर अगर मैं एक यूनिट horizontally move करूं तो y यूनिट्स कितने वेरी करते हैं. So y यूनिट्स जो हैं वो तकरीबन 24 से और 50 में जा रहे हैं. That will be clear when I stop using this annotation and work on this graph in order to expand it vertically. As much as possible, remove that annotation. And consider 3.3 again. Somewhere here is 3.3. And now I make a tangent line. Of course, I'm not still very good with use of mouse, making a straight line. The point is that जो हमारे पास वहाँ value आई थी, that was reasonably good. That derivative indicates slope of the tangent, and slope means 1 unit movement on x-axis produces how many unit of movement in the vertical direction. So that large value 27 के around जो थी, that is reasonable. और जितना मैं इसको स्केल पे ले जाऊंगा उतना ज़्यादा ये और reasonable नजर आना शुरू हो जाएगी. Okay, that is sort of a demonstration for considering the validity of results that we have just obtained, and that result was, sorry, annotation खत्म नहीं की मैंने. So this around 27 जो slope आया, that is a reasonably good result. So with that, I've reached at making you understand, or try to make you understand, that how for equally spaced data we can find the estimate of derivative. There is nothing new as compared to unequally spaced data. वहाँ डिवाइड डिफरेंस इस्तेमाल हो रहे थे, यहाँ फॉरवर्ड डिफरेंस इस्तेमाल हो रहे थे. द मेन डिफरेंस इज कि x, जिस x पे हम एस्टिमेट निकाल रहे हैं उसको हमने कन्वर्ट करना है s में. जब वो s में आ जाए तो अब x की जगह जहाँ x माइनस एक्स नॉट था वहाँ s आ गया, जहाँ x माइनस एक्स वन था वहाँ s माइनस वन आ गया, एंड सो ऑन एंड सो फोर्थ. The same difference that is there between divided difference interpolating polynomial and the forward difference interpolating polynomial. Rest is exactly the same. You should be able to use this formula that I had collected up to 4th degree term here. अगर मुझे इसमें 5th degree term तक जाना हो तो मुझे क्या करना पड़ेगा जी? Let me try to just show you that मुझे अगली टर्म तक जाना है तो मुझे क्या करना पड़ेगा. अगली टर्म में नीचे 1/5 फैक्टोरियल आएगा, ओह मेरा वर्ड जो है वो कुछ गड़बड़ कर रहा था. Yes, there is some problem with my word and it's not responding. Let me see whether it responds now or not. If it doesn't, I will terminate this discussion. I was finding out that ये 1/5 फैक्टोरियल हो जाएगा अगली टर्म. ये जो ऑर्डर ऊपर आ रहा है ये हो जाएगा 4, और ये जो प्रोडक्ट्स आ रहे हैं 3 के बजाय 4 होंगे. फिर गड़बड़ कर गया. Okay, forget about that. Forget about that.
सर आप इसको अगर डेमोन्स्ट्रेट करना था तो डायरेक्टली एक्सेल पे ज़्यादा आसान नहीं होगा?
फॉर्मूला जो है वो मैं एक्सटेंड करने की बात कर रहा था. I was not talking about anything else. That I can do manually also. So I don't bother about. मैं थोड़ी देर ऐसा करता हूँ कि ज़रा ये अपनी फाइल को रिट्रीव करने की कोशिश कर रहा हूँ. मैं 1 मिनट होल्ड कीजिएगा. I think I am successful in retrieving the file. ये terms हाँ, वो जो फार्मूला मैंने करेक्ट किया था वो ज़रा गायब हो गया है। जो रिट्रीव फाइल है उसमें जो फार्मूला मैंने अभी ये डिमॉन्स्ट्रेट करने के लिए ये वाला फार्मूला जो इसकी मैं 4th ऑर्डर टर्म पे जा रहा था वो नहीं आ सका। Anyways, I think I have completed the discussion on this and I want to go further for having estimates of higher order derivatives. अब तक जितना भी काम किया है हमने they were estimates of first order derivatives and for going higher order derivatives आपको याद दिला दूं कि at some stage x is equal to 0 which is equivalent to s is equal to 0 हमने जो पोलिनोमियल फर्स्ट ऑर्डर डेरिवेटिव के लिए जो पोलिनोमियल लिखा था इन टर्म्स ऑफ फॉरवर्ड डिफरेंस उनमें सिर्फ ये टर्म्स बची थी एस की कहानी खत्म हो गई थी बिकॉज एवरीवेयर एस वाज रिप्लेस्ड बाय 0 corresponding to x is equal to x naught. Where did we do that? We in fact did that whenever we obtained a derivative of a term and वो भी गायब हो गया सिर्फ यही बचा this one. This is copied there in order to develop techniques for higher order derivative. ये कैसे हासिल हुआ है? ये इस तरह से हासिल हुआ है कि हर टर्म में s की वैल्यू 0 रख दी जाए तो एक ही टर्म बचेगी जिनमें फैक्टोरियल्स आएंगे जिसकी वजह से डिनोमिनेटर के फैक्टोरियल्स जहाँ 2 फैक्टोरियल है वहाँ 1 आएगा ऊपर न्यूमरेटर में, जहाँ 3 फैक्टोरियल है ऊपर 2 फैक्टोरियल आएगा, जहाँ 4 फैक्टोरियल नीचे है वहाँ ऊपर 3 फैक्टोरियल आएगा. And plus minus signs will appear as somewhere you will have s replaced by 0 तो कभी -1 बचेगा, कभी -1 into -2 बचेगा, कभी -1 into -2 into -3 बचेगा. Accordingly plus minus signs will appear. So this is our launching pad for exploring few things, not so many things in this course, exploring few things about higher derivatives. Now we know that the forward difference that starts with x naught is this. That can fx1 minus fx2. That is the first order forward difference, which can be written as x1 is x naught plus h for equally spaced data, which can be written then as fxi का पे forward difference जो है that is delta fxi. That will be fxi plus 1 minus fxi and delta fi. These are notations. Now look at this here. If I have this as delta fi is equal to fi plus 1 minus fi, तो मैं इसको यूं भी लिख सकता हूं कि fi plus 1 is equal to delta fi plus fi. Now, like differentiation, delta is operating on fi. What is operating on fi in this term? In this term, it is delta which is operating on fi. In this term, it's only 1 which is operating on fi. So, जैसे कि differential equation अगर तुम लोगों ने पढ़ा हो तो function को तुम right side पे common ले सकते हो. ये लिखा होना चाहिए था delta plus 1 according to this, but I have written down this as 1 plus delta. Now, we define a stepping operator. 1 plus delta को जब किसी fi यानी fxi पे अप्लाई किया जाता है तो नेक्स्ट वैल्यू ऑफ द फंक्शन आ जाती है यानी f at x I plus 1. So taking lead from this line, this equation, I introduce a stepping operator कि अगर मैं fx naught पे stepping operator लगाऊं तो fx naught plus h यानी function value at next s x आ जाएगी. सो एफ आई पर जब मैं स्टेपिंग ऑपरेटर लगाऊंगा तो नेक्स्ट एफ आई आ जाएगा या वाई आ जाएगा। अगर मैं स्टेपिंग ऑपरेटर को एक दफा फिर लगा दूं तो इसका मतलब है उससे अगला एफ आई आ जाएगा। एक दफा फिर लगा दूं तो इसका मतलब है उससे अगला एफ आई आ जाएगा। लेट मी गो टू दी, सॉरी मैं तो कहाँ जा रहा था। I was going to start this annotation. Let us see that मैंने आज असल में वो मेरा जो वाइट बोर्ड है वो अवेलेबल नहीं है और मैं फ्री हैंड राइटिंग लिखने से कासिर हूँ। एक मिनट देखता हूँ शायद मिल जाए। होल्ड इट। What I'm suggesting is that अगर मैं यहाँ पे ये जो स्टेपिंग ऑपरेटर यूज किया है, मैं अगर y1 पे लगाऊं, y0 पे लगाऊं तो ये y1 हो जाएगा। क्या मतलब है? y0 जो है वो fx0 है, ये fx0 स्टेपिंग ऑपरेटर। अगर मैं y0 पे स्टेपिंग ऑपरेटर लगाया और फिर दोबारा लगा, that is equivalent to stepping operator applied on y1. That should be y2. That is what is being explained here. So in general, if I start at y0 and apply stepping operator 4 times, so that should produce what? पहली दफा लगाऊंगा y1, दूसरी दफा y2, तीसरी दफा y3। पहली दफा y1, दूसरी दफा y2, तीसरी दफा y3, चौथी दफा y4। चुनाचे I have a general formula available for stepping operator, and that is कि अगर मैं किसी ith y वैल्यू पे या fxi पे n टाइम्स stepping operator लगाऊं तो f at xi plus n यानी n step forward चला जाएगा। Now we have seen here that fi plus 1 is also produced by 1 plus delta fi. तो ये जो स्टेपिंग ऑपरेटर हमारा है वो दरअसल 1 प्लस डेल्टा, एंड डेल्टा मीन्स व्हाट? फॉर्मल डिफरेंस। तो मेरा स्टेपिंग ऑपरेटर जो है वो कोई नई चीज नहीं है बल्कि मेरी आवाज गायब थी क्या? हेलो,
सर आवाज आ रही है।
ये जब मैं स्टेपिंग ऑपरेटर डिस्क्राइब करता तो आवाज आ रही थी?
जी सर।
अच्छा, चलो। सो ये रिलेशन 1 प्लस डेल्टा और स्टेपिंग ऑपरेटर जो हमने इंट्रोड्यूस किया है, they have the same characteristic. So we consider this as a tool to exploit this original first order derivative estimate in order to find out how we can write down higher order derivatives. डेरिवेटिव के लिए भी हमारे पास dy dx के लिए भी एक ऑपरेटर है जिसको हम कैपिटल D कहा करते हैं। जब मैं किसी फंक्शन पर I'll apply this differential operator once, I'll get the first derivative. If I apply twice, I'll get the second derivative. If I apply d 3 times from the left side, I will get the third derivative, and so on. So in view of this, we start fi plus s as stepping operator E applied on fi s times. Now this s is the same as that we used in our interpolating polynomials for points representation in the equally spaced data. X minus xi divided by h is s. With this in our minds, we see what is the derivative of fi plus s. It is d by dx. D, capital D is d by dx, whereas fi plus s is ESFI. इसमें वेरिएबल सेपरेट करना है या वेरिएबल चेंज करना है, डी बाई डी एक्स की बजाय डी बाई डी एस लाना है, तो डी बाई डी एस से मल्टीप्लाई डिवाइड किया. We know that ds by dx is 1 upon h. The rest is d by ds of stepping operator of sth order applied on fi. Now, what is this? Why I have written in place of d by ds ln e? I have written this as ln e into e raised to power es by taking d by dx of e power x. I hope you remember that it is e power x. But what if d by dx of b power x is taken? Oh, it is mentioned here. It will be b power x multiplied by ln of b. So when I write down the derivative with respect to s of something raised to power s, I will have something raised to power s multiplied by ln e, a tool from calculus that we use here. So overall picture क्या बनती है? When I take the derivative of the function value at xi plus s, this becomes 1 upon h ln e raised to power s fi, where e is the stepping operator, h is the step in the data. And if I consider s is equal to 0, that means यहाँ पे 0 रखा और यहाँ पे 0 रखा. So first derivative estimate जो है वो ये आ गया. Now if e is 1 plus delta, हमने ऊपर इंट्रोड्यूस किया था कि e जो है 1 plus delta है. Hence derivative of function at xi, s0 रख दिया, is 1 upon h ln of e is 1 plus delta fi. That means हमारा जो डिफरेंशियल ऑपरेटर था, इसमें से f इस लास्ट इक्वेशन में से fi ड्रॉप कर दो, तो डिफरेंशियल ऑपरेटर जो है that takes the shape of 1 upon h ln of 1 plus e or ln of 1 plus delta या ln of e, which is a stepping operator. लेकिन ln of 1 plus anything from calculus is known to be for example, ln of 1 plus x is x minus x square upon 2 factorial 2 plus x cubed by 3 minus x4 by 4. So this d operator is 1 upon h delta minus 1 upon 2 delta square plus 1 upon 3 delta cube minus 1 upon 4 delta and so on. इसका मतलब ये हो गया कि अगर मैंने फंक्शन वैल्यू एट एक्स आई का डेरिवेटिव लिखना है तो इसके इस पूरे एक्सपेंशन के राइट साइड पे लिख दो. बट दिस इज नथिंग न्यू. This is nothing new. This is the same thing as this, where y नॉट की जगह एफ आई लिख दीजिए. लेकिन इस डिफरेंशियल ऑपरेटर या ऑपरेटर मैथमेटिक्स के जरिए हमारे पास ये टूल आ गया कि अगर फर्स्ट डेरिवेटिव ये एक्सपेंशन है तो सेकंड डेरिवेटिव इस एक्सपेंशन की ट्वाइस एप्लीकेशन होगी. थर्ड डेरिवेटिव इस ऑपरेटर की एप्लीकेशन ऑफ फंक्शन वैल्यू 3 times होगी, and so on. That help us in developing second order derivative formula. Of course, you have to multiply 1 by h with 1 by h, so 1 by h square. And these delta, forward difference operators have to multiply with each other. Least will be second order. Then there will be third order, delta into delta square 1 by 2. इसी तरह delta square 1 by 2 into delta, they add up to negative delta cube. इसी तरह delta पावर 4 की सारी टर्म्स इकट्ठी करनी पड़ेंगी. इसी तरह डेल्टा पावर 5 की सारी टर्म्स इकट्ठी करनी पड़ेंगी. So this 7 is our base for writing down higher order derivatives. From 7, if I use only the first term, that gives me the first order derivative approximation. From 8, if I use only the first term, that is an approximation of the second order. And similarly, nth derivative will be of this form. So ऑपरेटर मैथमेटिक्स जो है, ऑपरेटर अलजेब्रा जो है, उसके ज़रिए हमने हायर ऑर्डर डेरिवेटिव एस्टिमेट्स निकालने के टूल्स डेवलप कर लिए. The most commonly used formulas for derivative approximations. First order derivative, 1 upon h, first order difference. Delta fi is nothing but fi plus 1 minus fi, or yi plus 1 minus yi. Second order derivative, 1 upon h square into delta square. We know delta square means what? f2 minus 2f1 plus f naught. Third order derivative is 1 upon h cube into third order difference, etc., etc. There are some central difference formulas. यहाँ पे हम consecutive values ले रहे हैं फंक्शन की. यहाँ हम फंक्शन की 3 वैल्यूज में से मिडिल स्किप करके fi plus 1 minus fi minus 1. That is why it is called central difference. ये कैसे develop होता है, that I am not considering right now. Second order derivative के लिए central difference formula ये है. Third order derivative के लिए central difference formula ये है. इस तरह के और बहुत से फॉर्मूले डेवलप किए जाते हैं, किए जा सकते हैं. With that, I'll stop discussion today. मैंने ऑलरेडी ये अनाउंस कर दिया हुआ है व्हाट्सएप पे कि हम क्विज सेशन जो है वो कब करेंगे. हेलो. हाँ,
फ्राइडे 6:30 का लिखा.
फ्राइडे 6:30. आप में से शायद कोई साहब हैं जिन्होंने इससे पहले भी मुझे ये कहा था कि 6 बजे के बाद ना करें. तो मुझे अगर इफ एनीवन, मैं दोबारा उस पर व्हाट्सएप पे पूछ लूँगा. बट फॉर द टाइम बिंग वही जो मैं पहले अनाउंस कर चुका हूँ वही है टाइम. लेकिन इफ सम पीपल हैव प्रॉब्लम आफ्टर 6, I can have this on Sunday at 4 also. That we will discuss on WhatsApp. Right now, I stopped recording